All right.
Perfect.
So hold up this time. Let's hope we don't get this. Sorry.
Perfect. So.
All right. We're going away from CERN, but we stay in Ceph land. So let's welcome Victor. Give him some applause.
Hello everyone, thank you so much for being here. In today's session we are going to see how to deploy a hyper-converged infrastructure with Ceph across the Cloud-Edge Continuum. But first, let me introduce myself. My name is Victor Palma, Cloud Engineer at OpenNebula. I come from Madrid, Spain, and I've been working for OpenNebula for more than 2 years. Developing and innovating new features for the Cloud-Edge world. So first, we are going to start with some theory, and then my idea is to show you a demo of all the things that we are going to see here. Well, first, we need to do the question of what is the Cloud-Edge Continuum. The Cloud-Edge Continuum is just an environment of nodes on the edge, distributed in multiple locations, and everything interconnected using the same management layer. So use some advantages of the Cloud-Edge Continuum are the deployment of low latency applications. Since we are deploying our application near and closely to the final user, we can also reduce the energy consumption that our application does, since we are deploying the application in a small data center and not in a big one. We can also reduce the vendor dependency, since we are not deploying our application in a standalone data center like Cloud or AWS. We are deploying our application in multiple locations managed by any provider that we want at any time. Then we can improve the user experience using the Cloud-Edge Continuum for our applications. Since it's related to the first point, since we are deploying our application near to the user, the experience and the latency is going to be low. We can also expand the serviceability. It's very easy to duplicate and replicate our applications in different locations, different servers. We can deploy our application, for example, one Cloud-Edge in Paris and another one in Madrid. And if we want to replicate that, it's tan easy that replicate the same infrastructure in Lisbon or in London, and so on. And finally, we can reduce data transfers and reduce security risks, since we are running all of this in a local location near to the user, so that the data we need to transfer from our application to the user is more closely. So how can we manage all of this? How can we manage the applications in the Cloud-Edge Continuum? Well, first we need to have a set of clusters of bare metal servers. Ideally, running KVMs is the mostly popular hypervisor. Then we need a uniform management layer for handle and manage all these locations, are the private cloud associated with that. Then we need to interconnect all these clusters. And finally, we need to provide a multi-tenancy environment in order to create several users and groups and isolate each environment in the Cloud-Edge. We are going to see now an example of how a Cloud-Edge is inside. This example is as a scenario for a 5G radio. So we have this Cloud-Edge node connected to the 5G radio using a edge LAN and two servers. The idea of the Cloud-Edge is only have a small number of servers. In this case, we have two running the KVM hypervisor, and we can run in this hypervisor any application that we want. For example, a Kubernetes cluster for handle all the 5G core and the workloads, or even we can deploy an application for that use the virtual GPUs of the server if it's available for data processing. All the servers inside this node is connected to the internet through this public edge network using a single VLAN. And the idea of the cloud edge node is to be autonomous as possible. So if the single management layer that we are going to use is get down or it's not accessible, this site can work standalone and without any problem, and can still provide service to the user. So now we are going to bring these ideas to life and see how all these concepts match together in order to create our cluster. So how can we deploy a Cloud-Edge in the node? We are going to use three main technologies. The first one is OpenNebula. It's a platform for orchestrated virtual workloads. Then we are going to use Terraform to automate the resources deployment. And then we are going to use Ansible for the configuration side, for install the packages that we are going to need, etc. We don't need to use Ansible and Terraform directly. We are going to use that technologies through the One Provision portal. That's OpenNebula's tool that allows to us to automate all the configuration of the nodes and deploy a Cloud-Edge node in an instant with a few steps. One Provision supports several providers in order to create our own cloud node on the edge, like gcloud, AWS, or GAIAX. Some of them are currently in development, so not all are available, but well, we are going to use AWS for this example, for the example of the today's session. I would like to see more closely what is OpenNebula in order to understand the environment that we are going to see in today's demo. OpenNebula, as I've already said, is a platform that allows you to orchestrate and manage all your virtual machines, application containers, or Kubernetes cluster, all of them in the same way, in a very easy daily operation. You can deploy all these applications or all these workloads using your own private cloud, or expand your cloud to the public cloud or on the edge. OpenNebula has integrations with several third-party tools like Terraform, Kubernetes, Ansible, and Docker, and it also has its own built-in tools like Sandstone UI, it's the graphical user interface, the web portal that we are going to use to interact with OpenNebula. And we can create workloads in different hypervisors like VMware, KVM, LXD, or Firecrackers. So you can handle in the same way a micro VM or a virtual machine. It's for OpenNebula, it doesn't matter. Then we have the possibility in OpenNebula to expand our cloud to the multi-cloud or to the hybrid cloud. So in the case we have, for example, our own data center and we need more resources, we can deploy any infrastructure with automatic provision using, for example, providers like G-Cloud, AWS, or Equinix, and then have a uniform management for that resources with a homogeneous layer for user and workload management, and then deploy over the infrastructure any application that we want. For example, as I've already said, we can create Kubernetes clusters or Docker or virtual machines and so on. Well, we are going to use for the deployment of our cluster Ceph as a storage solution, but why Ceph? We are going to see Ceph basically because it's an easy way to distribute the storage of our cloud, of the file of our virtual machines, and share all the storage between the Cloud-Edge nodes in a very, very easy way. So Ceph at OpenNebula has implemented data storage based on Ceph that with simple configuration you can add multiple clusters or pools to OpenNebula. This shared storage implements replication and consistency, and some important features for Ceph data storage in OpenNebula are snapshot, clone operation, encryption, etc. Regarding Ceph at the edge, as I've already said, we need first a small number of nodes in our Cloud-Edge node. The Ceph storage is going to be dedicated to store VMs disk image. It's not necessary to have high storage requirements because we can use a multiple option for the storage. It has lowest storage requirements, and this is ideal for run in a HCI configuration because we can create nodes everywhere with a reduced cost. So the Ceph storage in OpenNebula consists of 3 different types of server. We have the full nodes that run the Ceph OSD, the monitor daemons, as well the KVM hypervisors as well. We have the OSD nodes to run Ceph OSD daemon, and the hypervisor only nodes that, as the name said, only runs the hypervisor. Here we have an example of comparison side by side from the point of view of the Ceph storage from the AWS and from OpenNebula. For AWS, we need to configure first a VPC, define then the metal barrel servers and all the routing tables and all the configuration that we need for our infrastructure. And from the OpenNebula point of view, we just only need to create our host and automatically associate it with the Ceph storage and we can start to create workloads on that servers. So Well, we are going to do a little demo on how we can do this using OpenNebula. So let me what I don't know displays, sorry. Okay, that's better. So this is the one provision portal that we are going to use to create the Cloud-Edge node. Here we can see a general overview of the clusters, hosts, and data storage that we have already in our infrastructure. So we are going to take a look to each section. For example, here we can see the providers that we have already configured. I have configured here the AWS provider for Frankfurt, is the example that we are going to see here, but we can create any provider that we want. For example, AWS or Equinix or on-prem. Here you can select the location for the provider, and when you finish this process, a provider is just a set of credentials that it's going to one provision. The thing that one provision do is use the API endpoint of each provider in order to create the host on the service on the provider. So it's just a set of credentials in order to connect to that endpoint using Terraform. Then we have the provision that are the provisions provided by the providers. And here I have already a provision created. I'm going to show you this provision as an example, but we are going to see how the process is. But I've already one created because deploying a node on the edge can take around 30 minutes. So in order to avoid that, we can see here, for example, this cluster already created and running. For create a new edge node, it's very easy. We just need to click on the add button. We can see here a description of the different options that we have, the supported virtualization technologies, etc. And we can set here if we want to create a edge cluster, or if we want to create a HCI cluster using Ceph. That's the option that we are going to use. Next, we can select the provider that we want to use. In this case, it's going to be AWS Frankfurt. General attributes like the name, the description. And here we can tuning or node, setting the number of instances, the number of instances for only hypervisors or for only Ceph OECD, etc., the DNS servers, the image that we want to use in the host. All of this configuration is also accessible through YAML files. And we can say, for example, here if we want to use virtual machines or micro VMs using LXC, etc. I'm going to back since this takes some time, but well, the result is this: a cluster created in the edge in a very easy way. So what is the result of this? We are going to see here. This is the main OpenNebula dashboard. The OpenNebula Sandstone is the user interface the web user interface. So here we can see all the virtual machines that we already have. We have some VMs already running here. If we go to this section, we can see here 3 nodes deployed on the edge inside this cluster. That is the cluster that we have created using one provision. And we can create and deploy VMs in a very easy way, downloading an appliance for the OpenNebula marketplace or from the Docker marketplace if we want to deploy containers in our cloud. We are going to deploy a VM as an example. So for example, we can, this one, on Alpine Linux, we can set here, for example, for Fosdem example, we can even set the host that we want to use inside the cluster. For example, we are going to use this one, but we can change any configuration of that VM. We are going to instantiate the VM. And here we can see that the VM is starting to be created. So it's going to take a few seconds since it's an edge location, but well, it's booting and it's running. It's totally running. We can see here the host where the VM is running, the start time. Well, a lot of configuration regarding the VM, like capacity or other storage and so on. And we can even connect to that VM. Oops, sorry. Maybe it's not totally ready. This one? Okay, I think that is I don't know if the Wi-Fi or maybe something is blocking me the connection to the VM, but believe me, it's working. It's working on my machine. But well, that's all regarding the demo. As you can see, it's very easy to create virtual machines in OpenNebula using a Cloud-Edge nodes. So returning to the slides. Okay. Well, that's the demo environment that we show you. Well, as final conclusion, the necessity of this project and this integration with Ceph and on OpenNebula are support for Ceph namespaces, support for incremental backup in Ceph, adopt Ceph image live migration. We want also to improve HCI configurations and integrate the one provision tool with the one deploy project that we already have. It's another public project that you can visit on GitHub that automates all the configuration and install of OpenNebula, and you are more than welcome to contribute to the repository on GitHub. And I also encourage you to contribute to our community, join to the forum, share your experience using OpenNebula, and help other users in order to create our cloud open source community. So this project is funded by the European Union, so it's very interesting, the project. It's Cognit, so you can visit here the URL. And Cognit tries to provide a cognitive serverless experience to the European Union, so we can. The idea of this project is to, using OpenNebula and one provision, create a lot of Cloud-Edge nodes in Europe in order to deploy application and gains independency of our cloud. And that's all. Thank you very much for your attention. Questions?
How do you deal with network outage, especially in the edge?
Sorry, can you repeat the question?
How do you deal with network outage, especially in the edge, where the connection might not be stable?
Okay. How can we handle the network connection when it's not stable? The idea of the edge nodes are that in this kind of a scenario, the node is totally independent, so it's still working even if don't have a connection to the internet, or at least to the region. I don't know if that's answered your question. So, yeah.
Just to understand properly so the configuration of the nodes at this point. So from the diagram, I see that you can deploy Ceph as a distributed storage subsystem on the same nodes where you're running also the virtual machine. Is that correct? Or you need dedicated nodes for the storage side and the VMs?
He's asking about if we can deploy in the same node the storage and the virtual machines and the other workloads. Yeah, you can deploy in the same node. From OpenNebula point of view, it's only one node.
Okay.
But behind it's handled in the splitting between Ceph nodes and the hypervisor nodes. But for the user that use OpenNebula, it's the host where he can deploy VMs and use their storage. So yeah. Any more?
Thank you.
Okay. You're welcome.